This is the third workshop in the non-visual data science workshop series. Welcome all. This one is I kind of it has kind of almost like two names, but I've kind of just updated it to a slightly more descriptive name, which is um, exploring and representing data. But originally I called it, which is a more exciting title, talking to your data, which I think is still a relevant uh, title here. And in this workshop, we will be exploring ways to represent different types of data, such as, we'll get to it in a minute, but categorical data, different kinds of data, time data, um, uh, other counts data, and binary data, all different kinds of data. And we'll be thinking about different ways to represent those non-visually. Traditionally, our most, in data science in general, often people will resort to visualizations to represent these kinds of data. We'll be doing it non-visually, and we'll also be talking a little bit about how to replace specific visualizations. So we'll kind of be trying to stay primarily in this non-visual realm, but I will speak sometimes to the practical elements of, like, well, what if my colleagues ask for a bar chart? What if my colleagues ask for a line chart? Something like that. I want to get a few administrative items out of the way. This is the midpoint in the workshop series. This is the third workshop. This is the last workshop that will be taught by me and my colleague, Sarah Kane, who's a Marshall Fellow at Cambridge in astronomy, will be taking over for the next two sessions to show you all sonification, which I'm very excited about. So we'll be switching gears a little, but we'll still be drawing on a lot of what we've learned in these first three workshops, and using, IPython and some of these other tools that we have kind of been using all along. Okay, let me go through there. Since it's kind of the midpoint, I want to go a little more in depth in some of the administrative stuff. There's been some questions that have come up a couple of times from people. Um, so I have a list here. Okay, yeah. So first of all, I'd like to thank those of you, or those, you've kind of maybe come to know them a little bit, the helpers who are hanging out in the chat, answering questions. So I just want to thank again Alex, Elizabeth, Sarah, Stephen, and also Paul and Monica, who I think Steve, Paul, and Monica aren't here today, but they've really helped things run smoothly and keep things humming along in the chat while people have questions. So thank you so much to the helpers. I'd also like to thank, there's been some participants who have been sort of very actively contributing. And I'd like to thank Nick Hilvora, who made some pretty extensive contributions to the first of the workshop series, the first curriculum for the workshop series. And he did that using GitHub. So he contributed using GitHub. GitHub is basically, you can think of it as a social media site for programmers, but where people store their source code, download source code. It's sort of social media meets infrastructure. And he used features on GitHub to collaborate and contributed to the workshops. And that's something you can do. You can just sort of do open source contributions to the curriculum that is currently hosted on GitHub if that interests you. You can also send ideas or updates or anything like that by email. I will say that, if you're interested in entering this field, it can be really useful to have a bit of a history of contributions on GitHub. And so this is one way to kind of get started with that. So you can either create an issue, which is basically like you telling me that there's something that could be changed, and then I'll change it. Or you can even do what's called a pull request, which is a little bit more complicated, but basically where you write up your own suggestions for how things should be changed, and I can accept it, pull it in. And then if you do that, you'll actually be a contributor on the curriculum, just like Nicole is now. So that's an option for you. If you're interested in that, you can drop me a line at patrick@iolaschool.com. Just if you wanted a little information on how to get started with those kinds of contributions, or if it sounds interesting to you. Okay, and then we also had another contributor, Peter Zygmunt, who is following along asynchronously, so probably not in the room. and Peter has been translating the curriculum to Hungarian, which is really exciting, and I'm excited to post that when he's completed it. So that's a very cool contribution as well. And I'd also just like, I think, to thank Chancey here, because I think, Chancey, you've helped me out with some of the ins and outs of using Zoom, and you just pointed out that I have a broken link on the curriculum and everything. So I really do appreciate everyone who's kind of contributed so far. Uh, let's see. One thing people have asked us about a lot is a mailing list for VI, data scientists, and people looking to get into data science or learning it. And I think that's a great idea. We have a lot of people signed up for this workshop series, and I think it's the basis of a good mailing list, you know. So I am looking into setting up or self-hosting a mailing list. If that doesn't go well, I guess I'll use free lists or something, but that, it's a little bit technically involved, but I'm hoping to set it up this week. So since a bunch of people have asked for that, I do think it's a good idea, and I think we're going to go ahead and set that up. So excited for that, and I will send an email to everyone who registered for this workshop when that is live, and also post on some of the main mailing lists like Python Viz and so on. Something else people have asked about is, I think there are some frustrations with GitHub, I think maybe rightfully so. And some people would find the raw markdown files that the curriculum is based on to be more useful. Some people would also kind of prefer to download the videos directly onto their computers, which I totally get. So we're going to try to facilitate that all by we're going to basically make sure the curriculum has a home that is a little more user-friendly. We're going to do that toward the end of this workshop series or right after the series concludes. And I also want to talk with the folks at Pandas to see if they want to host the curriculum or if we should create a new website for it. But basically, there will be a website for it, and there will be, we'll make it very easy for you to download the whole curriculum all at once if you prefer to have it on your computer, and also the videos to download directly. Okay. But that's not going to be right away, but it'll be probably shortly after this workshop series concludes in early March. Creating other tutorials. This is something I wanted to mention. We have a lot of stakeholders, stakeholders is a stupid word, but people who are very involved in various blind and visually impaired organizations registered for this, and people who are parts of other major organizations, whether it be academia, science, the blindness community. I'd just like to say, I think this has been a great partnership, and that NumFocus has allowed us to create this very cool curriculum, make it open to the public. I just want, I haven't pestered you guys that much about my own organization, IOTA, but I will say I would love the chance to create more resources like this for the blind community, to teach the blind community some more of these technical skills, and to create new curriculum, workshop series like this, recordings. If you're part of an organization where you think they might be interested in collaborating to create these kinds of materials, reach out. It can be I like, in the best case scenario, it would be for the public. That's kind of where I like to be. But also, I do work with organizations to create trainings specifically for your organization, or resources specifically for your organization too. Drop me a line if you think your organization would be interested in working with IOTA. And I'll just say like 2 sentences about IOTA. So IOTA is consultancy. I'm the head of principal consultant, and we do various things, including creating curriculum like this, teaching workshops, but also we consult on what I would say some tricky intersections between accessibility, writing, like creating a curriculum, and technology, so programming. Okay, so anything that kind of fits into those things, making web applications that have some connection to those things, stuff like that. That's where we kind of live. So reach out, and if you have any projects in mind, okay? And that's probably the only maybe one more little plug at the end of this whole workshop series, but please, let other people know about this IOTA or the kind of work we do if it comes up in conversation, because that's very helpful. It allows us to create things like this. Let's just see if that's everything. Okay, and then I'll just finally like to thank Pandas, NumFocus, and Patrick Hofler, core developer at Pandas or with Pandas, to for taking a chance on this workshop series and creating these materials, and they're really the reason that this has all been possible. So, all right, so that's more administrative stuff than usual, but it's the midpoint of this workshop series. So, okay, let's go ahead and get started with the workshops. We are first. First, I'm going to share my screen, and then we'll open up our IPython environment, and we will do a little discussion about different kinds of data. Okay, so I'm going to go ahead and share. There's checked for share sound. Share screen.
You have started screen share. Emacs ed Patrigam non-visual line zoom row 2 column Emacs ed Patrigam.
I am opening Anaconda prompt. I'm pressing the Windows button.
Cortana window.
I'm going to type Anaconda prompt.
Search box.
A.
Anaconda prompt left parent.
Yeah, I typed A, and that was enough, but you may need to type a little more in your case. Remember, you want Anaconda prompt, not Anaconda navigator.
Anaconda prompt left parent.
And then when you open Anaconda prompt, you have your command line. Regular in Windows, we call this command line environment CMD. There's also another one that some of you have been using called PowerShell, which will more or less work with this. But I find that the CMD environment is a little more stable for applications like IPython. And I'm going to maximize the screen. I'm also going to remove the title bar by pressing Alt-Enter. Okay, so now I have a nice, just the command line. Of course, the zoom is kind of blocking everything, but I'm doing things non-visually, so it doesn't matter. And then we need to start IPython, so let's type IPython, IPython.
IPython.
That didn't update, so that probably means my review is off. So let's double check that.
Report dynamic content changes on.
Okay, so it didn't say the usual version. Let's just do it again. I quit IPython. I'm typing the word exit to quit.
Left paren.
And I'm running IPython again.
Left paren.
So you can hear how it sounds when you start it.
Python 3.8.8 left paren.
So you'll hear and there's a whole bunch of other information, but you'll hear the version. Just a little review, and so to make sure you're all in the right environment. So what are we doing today? So a big part of data science is taking data that takes certain forms and then representing it in various ways. Okay. And we'll talk about the different forms and so on in a second. So what are the ways you can present data? So we'll talk, if you follow another data science tutorial, chances are the main way that they will represent data is through a visualization. And I looked up the definition of visualization on Wikipedia, and it was the most general sort of definition of all time. It was basically like everything, in the way they define it, everything is a visualization. Like every picture, everything is a visualization. But basically, my definition is a visualization would be it's a way to represent some kind of data visually. Okay. And the most common visualizations are things like charts and graphs, though there are other kinds of more complicated visualizations. And we'll get into some of but the most common charts and graphs would be things like bar charts, pie charts, line graphs, and scatter plots. Okay, there's a whole bunch of other kinds. I would say maybe 15 to 25 common visualization types, and then a bunch more esoteric ones. But those are the ones you're going to encounter most frequently in the wild, and that's they're the ones that people reach for most quickly. Okay. Now, what other ways are there to represent data? Since you and I and many of the people on this call don't maybe we use visualizations, but we don't really benefit from them in the same way that sighted people do. Maybe we have to use them to share with our colleagues or something like that, but we don't benefit the same way. you can use a sonification. So we're going to talk about that next week with Sarah's um, workshop on an introduction to sonification. Basically, it's a way to represent data through changes in sound, in qualities of sound. So a quality of sound would be something like the pitch. Sarah might have her own definition, but that's my probably not as good definition. Other ways to represent data might be text descriptions. So, I mean, we sometimes say alt text in certain contexts, but I would also, just the more general term would be a text description. So maybe the data is in some way described in natural language, you know. So if I say to you, oh, the data is it's two columns, and it's times, one column is times, one column is integers, and the integers are between 5 and 100, and they represent people's grades. You know, like that's a way to represent data, right? I'm telling you what the data is, gives you a general idea of the data. Maybe it's not quite as specific, but you know. Then there are other ways to represent data, but those are, I would say, are some of the big ones. Oh, the other one that I really want to mention is tactile graphics, which is a really cool direct way to experience uh, forms similar to visualizations, but they're really you access them through raised surfaces or other kinds of tactile interfaces, such as dots raised in a digital, some kind of refreshable braille display. And basically, it lets you use your hands, or if you don't have hands, another one of your another part of your body to experience the data manually or through tactician, through feeling. So for example, you might feel a line chart. I know, not Chancey, not to call you out again, but I know you did a bunch of work with tactile graphics early in the pandemic, when people were flattening the curve. So when you have that available to you, you can feel things like a line chart, which is pretty cool, and a very direct way to experience something like people usually use with the visualization. Now, today we're going to do something completely different, really. And there's not really a word for this. I call it talking to your data. Okay. And I would also say it's an interactive data representation is another, maybe that would be a more fancy way to say it. I kind of like talking to your data, though, okay, or a data conversation. And basically what that is we load our data into a manipulatable structure, like our data frame in pandas, like a series in pandas. And then we use programming to query the data, poke the data, transform the data, explore the data, and represent the data. Do all sorts of things with the data, and clean the data is also another thing that you can do. And do all sorts of stuff with the data. And there is pluses and minuses. We'll talk at the end about some of the advantages and disadvantages of this approach. I think in many ways it's a very exciting approach. And we're gonna jump in with that now. So what are we going to be representing in this workshop? So let's just really quickly talk about types of data that we'll be working with. Okay, and these are not formal types. Remember, in the first workshop, we talked about Python data types. So those were like things like a string, a list, an integer, which is a number, a float, which is a number, things like that. Okay, those are formalized because there's only a certain number of them. They exist in Python. They have certain formal ways that you interact with them. Okay, through programming. These categories I'm going to explain to you now. That I'm going to say types of data, which sounds a lot like data types. I'm talking about something different. I'm talking about very general ideas. Okay, so things like saying, if I say time data, there's nothing formalized about that. It can take a lot of different forms. It could be anything from a string telling you January 6th, 1995 with a comma and everything in it, to a number, which is the number of seconds since 1970, which is, surprisingly, that is actually something programmers do. They'll represent time as a number of seconds since a very specific moment in 1970, and that moment is called the epoch, which is pretty wild. Basically, it's almost like computer history started in a particular second in 1970, and we count from that point. It's one way to represent time. So that could be an integer, and the other one could be a string, and other ones could be, there's other ways to represent it, okay? More specific data types that are specifically for date and time. However, when we say time data, we mean data that represent points in time. So that's a more general concept, okay? What are the ones we're going to work with today? Okay, the main ones are numeric, which you've already worked with before in this workshop series. So for example, our prices of the Airbnb listings from last time were numeric data. What else is there? There's the other really big one that you'll hear a lot about, and people, this is as close to a formalized one as you'll get, is categorical data. Okay, categorical data represents a sorting into various categories, or kind of like buckets. It will sort each entity in a data set into one of a small set of categories. Okay, and we will make that a little less abstract in a minute when we work with it. Okay, there is also time data. I just discussed that. It's representation of points in time. And one other useful one to keep an eye out for is descriptive, or if you want to use a fancy word, nominative data. Basically, that's data that is a little more like a unique value. So something like someone's email address in a data set, or Airbnb listings that we have, or an ID number, something like that. Those things, they tend to be unique or a little closer to being unique, and they're usually used to identify things, okay? And for it, it doesn't usually make sense to order it, and it doesn't usually make sense to do things like get a mean or a median. Like if you get a mean or a median of ID numbers, that is literally, it's meaningless, right? Okay. So basically, it's just descriptive of an entity, but not useful in the same way like numeric data or time data or something is. Okay. Then I will throw in two other ones, and these are a little bit different because you will most often use these as an intermediate step when you work with data. And these, but you will sometimes find them in a data set directly. And those are the ones we're going to talk about today are count. So when you count things up, and then also binary data. So whether something, whether a thing about the entities is true or false. So for example, if we were to say in our Airbnb data set, it is underscore Brooklyn, we could make a new column called is Brooklyn, and that would be to either say true if the listing was in Brooklyn and false if it was anywhere else. Okay, that would be binary data. All right. And we'll work with most of these. We might not do so much with descriptive or nominative data in this workshop, but I wanted you to keep an eye out for it. But we will work with the other ones pretty directly in this workshop. Hopefully we can get to most of this. There's definitely a lot. All right, so types of data. Let's jump right in and say, let's work with categorical data a little bit, because this is one that I would say it's probably one of the most important to wrap your head around outside of straight numeric data, which we worked with last week, and doing things like the mean and the median. And so knowing how to work with categorical data is really critical for data science. And even especially when you're like starting an analysis or something like that. So you may be like, okay, I didn't really get your explanation of categorical data. Let's actually pull some categorical data from our data set, and then we will talk about what categorical data is again when we actually have an example in front of us, so it won't be as confusing and abstract. We'll actually have an example in front of us. Okay. So the first thing we'll do is we will pull in our data set. And it's going to be the same as last week. So I'll tell you exactly what to type. I will give you instructions for people who participated last week. I'll give you a little bit of a shortcut, okay? So you can type, you may be able to do this. DF space equals space, and then you can type a little bit of pandas, PAN. And you can, if you press the up arrow, it may fill in our URL and everything that we had before. So we fill in a bit of what you wrote before, and then if you press the up arrow,
:bit.ly/nycbnb quote right paren.
So it did fill it all
in left bracket 1 right bracket : df equals pandas.readline csv left paren quote http : /bit.ly/nycbnb quote right paren.
I'll go through that. Don't worry if you didn't catch that. I'm going to press enter.
Last right paren.
Oh, sorry, I skipped a step. You need to first import pandas. So IMPORT, IMPORT, space,
import,
pandas,
space,
PANDAS. Okay, you should get
in
no
left
output.
bracket,
And then we'll run our df equals, and I will go through it again. So you want to type, I'm going to run
in
it to
left
make sure it
colon,
works, and then I will go through it with you.
in left bracket,
Okay, worked for me. So what you want to type, if you, especially, if you don't have it stored in your history, I tried to tell you a way to access this line from your history from last week. If you don't have it in your history, maybe you're joining us for the first time, maybe you can't, it won't detect it for some reason. Go ahead and type this: df space, that's D as in dog, F as in foxtrot, and then space, uh, uh, equals space pandas, PANDAS, dot read underscore CSV, open parenthesis, and now you want to pin in a URL as a string. So we do a double quote, then do HTTP colon // bit.ly, bit period ly / NYC BNB. So that's Bravo, November, Bravo, New NYC for New York City, and then BNB like bed and breakfast. Okay, Bravo, November, Bravo. B as in boy, N as in Nancy, B as in boy. And then finish the double quotes, do a right parenthesis, and then run it. Okay. Hopefully, helpers, maybe you could also paste it in so people have the option to copy it. And it's also present in the written curriculum that we're going to follow along from. Okay. Once you have it loaded in, you should be able to do df. Just type df by itself, and you have your data.
F,
I did that a little fast.
D, F, out left bracket for right bracket colon. 48,892
That's enough. It's staying the number of rows, and there's a whole lot of information. We'll probably read for like 20 minutes if we, it's a ton of information. But basically, it's our big data set. We could do, you could do things like on it, like we did last week. We can do len on it to see how many rows, df.shape to see how many columns and rows. You could do all the things that we did before. df.columns to see the columns. These are things we all did in the last workshop. You could do them. This is the same data as we used last week in this data, in this data frame object. Okay. Okay, now we have our data in front of us. Let's pull out some categorical data and think about it, okay? And explore it. So I'm going to clear my screen because it helps me out cognitively to clear my screen before I do something new.
In left bracket 5.
So I did Control L, and I heard, in left bracket 5, right bracket, and it's the fifth. We're entering the fifth line that we've entered in so far into our IPython. Let's do df
DF
dot, and I'm going to type NEI
DF dot NEIG.
I typed in NEIG, and I'm going to let it fill it in for me by pressing tab. Okay, so go ahead and press tab.
Neighborhood.
You heard
neighborhood
because it was filling in the rest of the word neighborhood. I say to do this because for some reason this data set, it spells, it's fine. But some of us are Americans. We don't use the U in neighborhood. Okay. So in British English, they say a neighborhood with a U. In American English, we don't do the U. So this is a point of confusion. But in this data set, it's actually spelled the British way. Okay. So I recommend using the tab and just letting the computer fill it in. Then there'll be no confusion, no problems. Okay. You can I recommend that to do that whenever you can. Okay. So we want to do df.neighborhood, and then I'm going to do a period. So remember, it's neighborhood with U, dot head.
In left bracket HEAD head. Left paren, right paren.
So we did head, left parenthesis, right parenthesis. So it's got df.neighborhood.head. Okay. And we should get the first 5 items from this column. Okay. The neighborhood column in our Airbnb data set. All right. We're getting the first 5 items.
Out left bracket 5 right bracket colon. 0 Kensington. 1 Midtown.
Oh, I'm sorry. I meant to do a, this is fine actually for, so this is our data for individual neighborhoods. What I actually wanted to use is neighborhood group, which will tell us something a little more specific about this categorical data. So if you want, you can type it again. That's probably the easiest way. You can also press up and backspace your answer. I'll type it again. So I'll do df dot
Borhood.
I'm letting it fill it in.
Neighborhood.
And then I'm just going to do an underscore
line.
And
in
press
left
tab
bracket
again,
6 group.
And then fill in group. So it's neighborhood underscore group. df.neighborhood underscore group. That's what we want. And essentially, you'll see in a second, but this corresponds to, if you're familiar with New York City, the different boroughs in New York City. So Manhattan, Queens, Staten Island, the Bronx, and Brooklyn. Okay. So and that's our column. Let's do head. So we only got the first 5. So it should be df.neighborhood underscore group dot
HEAD.
open parenthesis.
Head. Left paren, right paren.
Okay. So open paren, close paren. df.neighborhood underscore group dot head, open paren, close paren.
Colon, right paren. Out left bracket 6 right bracket colon. 0 Brooklyn. 1 Manhattan. 2 Manhattan. 3 Brooklyn. 4 Manhattan.
You'll notice something, and this is what I wanted to show you, and this is why the neighborhood wouldn't really help us with this. That this is the main characteristic of categorical data, is that the values are repeated. Okay, so this column consists of a relatively small set of values. So Manhattan, the Bronx, Queens, Brooklyn, and Staten Island, and they're repeated over and over again. And when they appear in this column, they tell us that the item in the row, the entity, which in our case, it represents an Airbnb listing from 2019. Okay, each row in this data set is an Airbnb listing from 2019. And when one of these items appears in this column, it tells us, hey, that listing is from the Bronx, it's from Queens, it's from Manhattan. Okay, and you'll notice the 2 here that are appearing most frequently are Manhattan and Brooklyn. Okay, we can confirm that in a minute. But when you see repeated data like this, when you see repeated information, and it could be numbers too, but if it's a small number of items that are repeated, then that gives you an indication that it's categorical data. Okay. Also, if you think about, hey, this could basically be considered a category. So something like neighborhood group, that sounds like a category. A neighborhood sounds like a category. Okay. Then it's going to be categorical data. It sorts the entities in the data set into various little buckets. Okay. Now, what do you do with categorical data? How do we represent it? How do we explore it? So the first thing you should do with categorical data typically is to get a set. Okay. So there's 2 things you should do right away with categorical data: to get a set of all the categories, and then to count the various items. Okay, these are the 2 things we're going to do in order. Okay, so let's do what the line we had before, but now we're going to put the function set around all of it. Okay, so I'll type it again. Set
SET
open parenthesis
set left paren
and then df dot neighborhood underscore group
NEIH Borhood line.
That's the line is underscore
rope
group. So it's neighborhood group underscore group dot and let's not do the head. It doesn't really matter here. So we could do set df.neighborhood group.
Right paren.
Set open paren df.neighborhood group right paren.
Out left bracket 7 right bracket colon, left brace Bronx, Brooklyn, Manhattan. 10, Queens, Staten Island right brace.
Those are our 5 items. Bronx, Brooklyn, Staten Island, Manhattan, and Queens. Okay, those are the 5 items. Those are our categories, and we use the set function. Basically says, give us the unique values from this data set. Okay, and what it returns here is a list-like object, which is a set object, but it's very similar to a list. Okay, that tells us how many categories we have to work with. The other thing that I recommend doing with with categorical data, once you know that it is categorical data, or even if you suspect it's categorical data, is to count it. And I would also say that set is very good at telling you, is this categorical data? And if you run the set function on a column, then you will learn, you will see, oh, is it a small number of categories of repeated values? If it's a small number of items that come back, then that's a strong indication that what you're working with is categorical data. But if it's as almost as many items as we have rows in the data set, then it's probably not categorical data. It's probably something like descriptive or nominative data. Okay, like if you ran a set on email addresses, it'll pretty much be the same number of items as the full data set. Okay. So let's do a count. Okay, and we'll talk about counts. So let's do df.neighborhood group again.
neighborhood group.
Remember, I'm making a lot of use of tab here. This is where tab is going to come in useful. We're going to be writing longer lines in this session. So we're going to be doing, I'm going to use tab a lot more. Hopefully you're getting a little bit used to this environment. I will also say, if I'm moving sometimes a little bit fast in these workshops, which is kind of the nature of some of these more online workshops. In-person workshops, I tend to go a lot slower and leave time to work. But we're kind of doing things for the recording a little bit, and you can review the recording
raised hand
afterward. There's a raised hand. We'll get to that in 1 second. There's a recording and there's a written curriculum. So if you're feeling a little stressed at any point in this workshop, just remember that those resources they're available to you. And Sarah and I are available. We're just an email away. And there's also the office hours on Thursday. So a lot of resources available to you if you're feeling a little learning stress. Okay, just saying. We had a raised hand. Is that a intentional raised hand? And we can, if you want to get on the mic and ask a question, you're welcome. Okay. I hit that button all the time myself too. So if you do, if it was a question you wanted to ask, just feel free to get on the mic and ask it. But okay, so df.neighborhood group, and now we had df.neighborhood underscore group, and now we're going to use a new method, and we're going to use this method a lot. Okay, so try to remember what it's called because we're going to be using it a lot. Okay, but you'll get a little reinforcement as this goes on. Let's do it's df.neighborhood group dot value underscore counts.
Dot VALUE line COUNTS counts. Left paren, right paren.
So it's df.neighborhood underscore group dot value underscore counts, open parenthesis, close parenthesis. I kind of hate the name of this this method because it's hard to type. It has an underscore in it. It's kind of long, and I use it a lot. It's one of the methods I use the most when I'm doing data analysis. Okay, so but we're going to use it a lot too. So remember that tab is your friend. In this case, it might not be that useful to you, but All right, let's run it and see what we get.
Out left bracket 8 right bracket colon. Manhattan 21,661. Brooklyn 20,104.
So okay, what are we listening to here? We'll resume in a second. We're hearing a series which has labels. Remember from last week, we have the series is represented with 2 columns. For us screen reader users, it's that each line has on the left first a label, okay, which is the index, and on the right it has a value. In this case, it's a number, okay? So we're listening to a series. The labels are the categories, okay? So Manhattan, Bronx, Brooklyn, etc., that we got from our set. These are the unique values in this column, okay? And then the rightmost column, or the rightmost item in each line, is the value, okay? Which in this case, because we're performing a count, we created a count. It's the counts. It's how many times each of these items appears in the data set. Okay, so we heard Manhattan was something like 21,000 something something. Brooklyn was 20,000 something something, so a little bit less. Let's listen to one more.
Queens 5,666.
So Queens, there's a bit of a drop, 5,660 something.
Bronx 1,091.
Bronx is another drop. Okay. So you're hearing the values, and it's pretty intuitive, right? So it tells us how many of the 40,000 something items in our data set, 20,000 some odd are Manhattan, 20,000 some odd are Brooklyn, about 5,000 are the Queens, and about something like 1,000 are Bronx, and a very small number presumably are Staten Island. I guess we could listen to that.
Staten Island 373.
Only 373. Very few Airbnbs on Staten Island. So if you want to run an Airbnb, don't open it on Staten Island, I guess is my advice. Maybe open it in Manhattan or something. I don't know. And I'm not in that business, so don't take my advice. And then at the end, it'll say the D type. Remember, series always tells you the D type.
Name : neighborhood line group, type : int.
D type int. So it's integers. The items in this are integers. Okay, they're counts. Now, okay, let's talk about this a little bit. Okay. First of all, this is already very useful. You've pretty much, if you've ever been familiar with a bar chart, some of us are, we have partial vision. Some of us used to be sighted or more sighted. Maybe you're familiar with visualizations. Okay, you know what a bar chart looks like. I'll just quickly describe it. A bar chart basically it represents data with how long different lines are. Okay, so if a line is longer, it has more items in it. Okay, basically what we have here is it's a bar chart. Okay, it tells us how many items there are. It's almost like if we were going to take a bar chart created by a cited data scientist and represent it in some format that is accessible to the visually impaired, we might actually pick a format like this, and it actually would be pretty good. You might have your own preferred format, but this one's actually not terrible. Okay, it has a label, it has a number, each pair is on a line. It's actually pretty usable. Okay, so basically what you have here is a bar chart. Okay. Now, how is it different from what could a sighted person do a little more advantageously with a bar chart that you couldn't do with this? My answer to that is, first of all, not that much. But if I had to say one thing, it would be that the sighted person might get very intuitively to their mind the difference between the different items. Okay, so instead of hearing or seeing the very specific numbers, they might be like, oh, okay. They might get an insight, like, for example, Brooklyn and Manhattan are really close together. There's a pretty big drop-off between those two and Queens, and then another big drop-off between Queens and the Bronx. Okay. Now, to be honest, you can get that from these numbers pretty easily. Okay. But let's make it even more like a bar chart. And also very similar to a pie chart, because if a pie chart represents data by it draws a circle. So if you imagine make a circle with your hands, and then different slices on the circle represent the proportion of each item in the data set. Okay, so we have about 20% of the items are Brooklyn. So if 20,000 divided by some 40 something thousand would be something like 40 something percent. Okay, just to do some back of the napkin. So we would take out a slice of the pie that would be 40 something percent. That is basically how a pie chart works. Data scientists actually hate pie charts, and they look down on people who use pie charts. But in my experience, people, like many bosses and stuff that I've had, like pie charts. So, mostly things that you could do with a pie chart, you could do with a bar chart, and probably better. But so basically what we're doing here is we're thinking of ways to replace both pie and bar charts. Okay. But what we're going to do now is even more like a pie chart. And it also will give you a little more of that intuition of the differences in the sizes. Okay. So let's use the second technique here. So you already basically have replaced bar charts, I think. And bar charts are one of the easiest to replace non-visually, in my opinion. But let's make it even better. Let's make our representation, our non-visual representation, even more like intuitive to us, okay, or even more useful. So let's do this. First, let's save our counts to a variable, okay? And I'm going to tell you how to do that with some hotkeys, okay? If that's okay. So if you prefer to type it all out, that's fine. And we'll go over that as well. But let's press the up button.
Colon, line counts left paren, right paren.
That loads in the last line we ran. So that will be the one that where we get our counts, okay? Now press Control A to go, and you won't hear anything. Just press Control A to go to the beginning of the line. And then type, let's just call it neighborhood counts, okay? And you can spell neighborhood any way you want. I'm going to spell it the British way, I guess, because that's closer to the dataset.
Neighborhood line
underscore
COUNTS.
And then I'm going to do a space
SDF dot
and a space and equals and a space.
Space equals space.
So what I'm doing
DF
is
dot N.
I'm saving the last line to a variable. Now you could also do a really quick way to do this is another cool way to do this is you could type neighborhood underscore counts equals underscore. And because underscore actually represents the last line you put in, which is pretty cool. And that's one of the contributions Nick Hilvora made when he edited the first in this workshop series is he added a description of that underscore that IPython lets you do, which is a pretty cool trick. But so you could do that, or you could do what I did, which is to press up, move to the beginning of the line with Control A, and then type it in, okay? Because who wants to type everything over and over again? Certainly not programmers. Programmers are lazy.
In left bracket 10 right bracket colon.
Okay, so basically what we did there is we saved our previous counts to a variable. So we did neighborhood underscore counts equals df dot neighborhood underscore group dot value underscore counts. Okay, and we didn't want to type it all, so that's why I showed
Ibrahim Vast raised hand alert.
If someone wants to get on the mic with a question, that's fine. I'm hearing raised hands, but maybe actually just type in the chat if you want to raise your hand because it may be accidental hand raising, which is something I very frequently do in meetings. Because I often want to look at the participants list and then I raise my hand by accident. Okay, so we now have neighborhood underscore counts. So that's our counts that we were just looking at. The 5 items, each with the label of the borough, Manhattan, Bronx, the neighborhood group, and then the count, the number of times it occurs in the data set. So that's what we have saved to the variable. What we're going to do now is neighborhood underscore counts.
NEIG8 in left bracket line.
Did it do it?
Space. In left bracket B.
My
root line counts.
Oh, it filled it all in. Neighborhood underscore counts. So I use the tab to fill it in. You could type it all out yourself too if you prefer. It's neighborhood underscore counts. That's the variable we created. And now what we're going to do is it's a new technique. We're going to get the proportions of the data. Okay, so and they're going to be kind of like decimal points, kind of like fractions that are going to represent how much of the data is each item. Okay, so we're going to do divided by
space.
So it's neighborhood underscore counts divided by
slash space.
Len for length.
LEN. Len. Left paren.
DF.
Left paren. DF.
Right paren.
DF.
So it's neighborhood underscore
right paren.
Neighborhood underscore counts. Then a space, a forward slash, a space. Remember, forward slash is divide, and then len open paren DF close paren. And so basically the len df tells us the total number of items in the data set. So that's 40 something thousand. That's all the items, all the listings in this data set. And then so what this is going to do is going to divide each item in our counts by the total number in the data set. So Manhattan is 21,000 something. It's going to then divide that by 49,000 and something. Okay. And what that will give us is a decimal that will tell us the proportion of the items in the data set that are that. Okay. And remember, we said it'll be something like 40 something, 0.44 or 0.43. It'll be something like that. Okay. And that will tell us that 43% or whatever of the items are Manhattan. But anyway, let's run it and see what it sounds like. Okay.
Out left bracket 10 right bracket colon. Manhattan 0.44.
So you hear that 0.44. Okay, so that's about 44% of the items in this column are Manhattan. Okay, so 44% of the Airbnb listings in 2019 were in Manhattan.
3011. Brooklyn 0.4111.
Okay, Brooklyn 0.41. Now you can tell even more intuitively these are very close to each other. So 44% are Manhattan, 3% less, 41%, something like that, are Brooklyn.
67. Queens 0.115.
Queens 0.11, that's 11%.
5881. Bronx 0.022.
Bronx 0.02, only 2%.
313. Staten Island 0.00.
Oh, Staten Island is tiny. 0.00
762.
76. So less than 1%. 0.7%, less than a percent of the items are Staten Island. Sorry, Staten Island. Okay. And then, so that's pretty cool, right? So we're actually getting proportions. So now, not only replace the bar chart, we kind of replace the pie chart too, you know, because now the pie chart tells you the proportions of each item. And what this does, this tells you the proportions, okay? And let's do one more useful thing, okay? And I would say sometimes you might just want to leave it there at proportions. This will tell you pretty much tell you the same data that someone using a bar or pie chart would. And pretty much the same, and honestly, it's very usable. It's good. Like it's pretty straightforward to replace a bar or pie chart non-visually. And even there's actually some slight advantages to this, because sometimes it can be a little hard to read a pie chart if there's a lot of items or so on. It's not a problem. That's another thing about bar and pie charts is that usually sighted people can only put so many items in them, usually a relatively small number, probably not more than like 20, and usually more like 5 or 10. And a pie chart really does very poorly with anything more than, in most cases, 5, 10 items. That's about as many as you could put in a pie chart. Because just reasons, you know, it just doesn't look good. It looks bad, and it's hard to read if it's too many items. So actually, you don't really lose out that much with this, because already sighted people can only intuitively grasp a relatively small number of items in a bar or pie chart. And so we're actually not at that much of a disadvantage with this type of data. Let's do one more thing, which I think is pretty cool. It might even kind of be in some ways better than a pie chart or a bar chart. And certainly a pie chart, but maybe in some ways even a little better than a bar chart, or show something kind of cool. So let's do this. We'll do our neighborhood counts.
N-E-I-G-A in left bracket 11 right bracket colon neighborhood line counts.
So neighborhood underscore counts. Remember, that's our number of counts of each item that we created. And then let's do dots. And this one always is hard to remember, but I think I've got a grasp on it. Dot PCT.
P-C-T.
That's short for percent. I always want to say it should be PER, but whatever. I didn't get to name these, so you know, they didn't ask my input when they created all this stuff for some reason. I don't know. PCT underscore.
PCT. Line.
Remember, line is underscore.
CH. Colon. Eng.
Okay, that was hard to understand. But basically it's neighborhood underscore counts, our variable, dot PCT underscore change. That's for percent change. And then do an open parenthesis and a close parenthesis.
Left paren, right paren.
And then let's listen to this. And we will see what we get. I think this one's pretty cool.
Out left bracket 11 right bracket colon. Out left bracket 11 right bracket colon. Manhattan NAN.
Okay, it said Manhattan NAN. I'll explain that in a minute. Basically, no data.
Brooklyn minus 0.0718.
Brooklyn minus 0.07 something something. Okay, so that is actually what that's telling you is between Manhattan and Brooklyn, it decreased by 0.07%, 7%. Okay, remember that these decimals are another way to represent percentages. Okay, that says it decreased by 7%. So from Manhattan to Brooklyn, it decreased by 7%. Let's hear the next one.
880. Queens minus 0.7181.
Okay, Queens was minus 0.71. So Queens is almost a 70% drop from the previous. So this tells you what this tells you is the percentage change from the previous item. So it only changed 7% between Manhattan and Brooklyn. So those are pretty similar. Then between Brooklyn and Queens, it dropped 70%. So that's a big drop. So this is telling you, now you're getting exactly what a sighted person would get from the bar chart, that intuition about the change, okay, and the groupings, okay, that you can get, oh, that changed a lot. Okay, and let's just hear the rest. Just
6.6. Bronx minus 0.807.
Bronx down 80%. Okay, so it's an even bigger difference from between Brooklyn and Queens. Okay, and that's something that's hard to get just from the numbers. Okay, and what we're getting is actually even a little more precise. You know, because you wouldn't get the exact numbers. You get an intuition with the cited visualization, but you won't get the exact numbers. So actually, I think this is cool. Let's just hear the Staten Island for fun. It's going to be big.
448. Staten Island minus 0.658.
Staten Island down 65%. Okay, so the biggest drop is between Queens and the Bronx. Okay, but also another big drop was between Brooklyn and Queens. Okay, so this tells us a very intuitive way of telling what you would get in a bar graph, which is this: how big are the changes? Okay, that's what you would get with a bar graph with the difference in the line. So this is a very, let's say, a very adequate, or actually pretty good replacement for a bar or pie chart. Okay, which are, I will say, those are probably arguably the most used visualization would be a bar chart. Maybe you could say a line chart. I would say it's kind of a toss-up between bar and line chart are the most commonly used visualizations. We've kind of already sort of have a pretty adequate replacement for the bar chart. Okay. We are going to move on to the next section. I'm going to do a time check, and then if people maybe have a question.
2:00 p.m.
Ooh, we're exactly at the halfway point, which is exactly where I want to be. Love that. All right. Do people have any questions, or do the helpers want to kind of kick up any questions that were coming up a lot before we move on to the next section? Okay, we already replaced bar and pie charts. Admittedly, those are kind of the most easy to replace non-visually. Okay, and we're going to kind of get into some harder to replace ones, but we already have a win under our belts. Okay.
It's been remarkably quiet in the chat, so I suppose if anyone has, I know. So if anyone has questions,
can we wait? I would love. I'm going to do a long wait. I would love if someone were to ask a question at this juncture. So you're doing me a favor if you ask a question. So, if you feel so inclined, just go ahead and turn on your mic and ask a question.
would sorting...
Ibrahim is asking, would sorting the data first the data sets first give you a better indication of the differences?
I would say one thing is that the counts are automatically sorted. Okay, usually from greatest to least. Okay. Now, I will say we will be using sorting more before we're through here, and sorting is really useful. But in this case, you kind of get the sorting free with the counts, so it's not really, I don't think, necessary. You can sort the categorical data, but really what you're going to get if you sort it is just
reacted with colon.
Sound something like Manhattan, 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 Manhattan. It'll sort it into alphabetical order, and then you'll just get a lot of repeated values. You'll be like the Bronx, the Bronx, the Bronx, the Bronx, the Bronx. So I would say sorting the column by itself doesn't really tell you that much. But sorting the counts is very useful, and you get that kind of for free. So usually by default, it gives you from the biggest value to the smallest value. So they call it descending order. It gives you descending order. Okay, great question. Great question. Thank you for asking it. Did Sarah, was it Sarah or someone was starting to say something there, or?
The exact same question. Excellent. So
thank you, guys.
Nothing further here.
Cool. Well, thank you. Is that Prima? Thank you. I really appreciate the question asking. So, okay. So if people have other questions, please place them in the chat. I love those long, awkward pauses when I do remote teaching. So I live for that. So I will maybe ask for more questions later in the workshop. Okay. Okay. So we started out with counting, which is one of the favorite tools in my toolbox, and I also showed you a couple of other cool tricks, which are the getting the proportions, those little percentages, and the percent drop or the percent change, which is quite useful. I will say I'm just going to gesture toward the written tutorial here, because we don't have time to cover all of this. But I anticipated a couple of frequently asked questions at this point, and those are, one, say I want to work with cited colleagues and I want to make an actual visual bar chart or an actual visual pie chart. How do I do that? Okay. Now, why no, I mean, I'm just kidding. No, I mean, we live in a cited world. Last time I checked, and we work with cited colleagues, and sometimes it's useful to actually create the visualization. So I did give instructions for creating a visualization of our counts data in the written tutorial, so you could check that out. Another thing is, question is, can you get actual percentages? And I give instructions for that too. If you don't want the decimals, there's a way to actually get nice looking percentages. It's a little bit involved, not terribly involved, so we're not going to cover it here. But that information is there in the thing. I had another one FAQ, but let me just check.
Emacs Ed Patrick I search creating bar chart, skipping the divide step, creating tidy percentages.
Oh, you're right. You can and also one useful thing is that I won't cover here, but it's in the tutorial, and the written tutorial is a way to skip the step where you divide by len data frame. There's actually a way to skip that step and to just change the value counts a little function a little bit. You add normalize equals true into the parentheses, and that will let you skip that divide step, and it will give you those proportions directly. So check those out in the written tutorial. I'm not going to cover them here, but those are my guesses at things you would want to do with this categorical data at this point. Okay. You can always send me emails and I'll add to that. All right, so I'm going to now show you, maybe in my personal opinion, the next kind of really cool tool in the toolbox, in this data exploration and representation toolbox, which is indexing. Another way I would say this is using binary data. Okay. So what we're going to do here is that we're going to look at our full data set. So we have a full data set, which of 49,000 rows. Now, let's say we want to answer a question not about the full data set, but only about a specific portion of the data. So for example, the example we're going to use is, say we only want to analyze rooms that are really expensive, so over $1,000. Okay. Maybe you're deciding if you want to eat the rich or something like that. So we'll look only at the expensive rooms. So what we can do, and this is what I'm going to teach you, is you can make a new data set that is a subset of the old data set for which something specific thing is true, for which a specific statement that we make is true. For example, you could say, okay, I want to make a subset of the data where the price of each listing is over $1,000. Okay, well, $1,001 or more. So we're going to do that now. So let's clear our screen, clear our minds. Control L.
In left bracket 12.
So we've already entered 11 lines of code. We're on line 12 here. And now let's do our indexing. And I would say this is probably maybe one of my top most used techniques when I'm doing this, is creating these subsets of the data. Okay, so this is a pretty cool one. So, and very flexible. So we're going to do this in 2 steps. First, we create a series that is, it's going to be a series containing binary data. Another way of saying that is it's a Boolean series. Okay, Boolean, say kind of the same as binary, true or false. We're going to create a series that only has true or false values, and those are going to correspond to what we ask for. So we're going to say, create a Boolean series where it'll be true if the price for the row is over 1,000, and false if the price of the row is less than 1,000. So that's our first step. And we're going to go and save it to a variable right off. Okay, so we'll do, I'll call it expensive underscore bools for Booleans. Okay.
EXPENSIVE. Expensive. Line.
I did an underscore there. BOOLS.
B-O-O-L-S.
Expensive underscore bools. That's going to be our variable name for our Boolean series of true false values.
Bools equals
Equals.
space.
And let's do df
df
dot price.
P-R-I-C-E.
And this is where we specify what we want. So I'm going to say greater than
Price.
I did a space.
Greater. Space.
1,000.
1 0.
I did 3 zeros there. 0 0 0. So it was. So what we put in is expensive underscore bools equals, for assigning the variable, df dot price greater than sign 1,000. Okay. You can remember, you can leave off the spaces if you're not feeling it. I put the spaces in because, you know, that's what they tell you to do in programmer school, which I never went to. But okay, so I'm going to press enter.
In left bracket 13 right bracket colon.
Okay, so remember, when you assign variables, you don't get any output. You just hear the input line again. Remember, that's the way of thinking about that, is that the data that we would normally hear with the screen reader, or, you know, see, perceive, depending on how you're using it, goes into the variable. Okay, it doesn't kind of like come out into our our command line environment. Okay, that's one way to think about it. So let's check out that that series. So let's do what did I call it? Expensive underscore bools.
Expensive line bools.
Dot. Expensive underscore bools dot head.
Head,
And I just
right
use
paren.
head a lot because I don't want to hear too much output. Okay, remember, head will get you the first 5 items. So head is very useful to just get a little bit of the data so you can kind of get a sense of it.
Out left bracket 13 right bracket colon. 0 false. 1 false. 2 false. 3 false. 4 false.
Well, that was pretty boring because they're all false. But most of the listings are not over $1,000, right? I mean, you know, thank the universe, you know, because like, you know, I can't afford $1,000 room. But we could do df. So now we have our booleans, but now how do we tell if there's actually any trues in here? So the two things you can do with the Boolean series by itself that I recommend are, here's a little trick that I really like. Okay, I haven't really seen this anywhere. I don't know where I picked this up. Maybe from a colleague or something. But you could do price or expensive underscore bools.
Expensive line bools.
Expensive underscore bools dot mean. So get the mean.
Dot.
M-E-A-N.
Mean. Left paren, right paren.
Get the mean of the Boolean series. And what this will do is it'll tell you the percentage, there's percent that are true.
Out left bracket 14 right bracket colon. 0.004888.
So 0.004, about 0.5% of them are over $1,000. That's still a good number. Okay, so we did expensive underscore bools dot mean, open paren, close paren, and that told us the percentage in a decimal of the items that are true. Okay, that's a cool trick. So we do know there are some in there, and now let's find out exactly how many. So we can also use, remember we said we used our value, we had a method value counts. You can also count the true and false values. So let's do
Expensive line bools.
So expensive underscore bools dot, remember using the tab, that's why it's saying it that way.
Dot.
Expensive underscore bools dot value underscore counts.
V-A-L-U-E.
Value. Line.
C-O-U-N-T-S.
S. Left paren. Right paren.
Okay. So we have, we're using the value counts method on our Boolean series to count the values.
Out left bracket 15 right bracket colon. False 48,656.
That's 48,000 something. That's a lot, but it's not all of them.
True 239.
239. So we have 239 values in here that are true. That means there's 239 rows in this data set where the price of the room is greater than $1,000. Okay. Now let's do the really useful thing, which is we're going to create a new data frame. We're going to call it expensive underscore DF, expensive data frame. It's a new data frame, right? We can't just keep using DF1, DF2, DF3. Don't do that. Don't do that to yourself. Once you go beyond using one data frame, you want to give it a name that's kind of somewhat useful. We'll call it expensive underscore data DF. And then what we'll put in it is only the items where the room is over, where only the rows where the price is over 1,000. Okay. So we do expensive
EXPENSIVE
underscore DF
expensive line
DF
space equals
space
expensive underscore DF space equals space. And let's do DF, our original data frame.
DF.
And now we open square bracket.
DF left bracket.
And now we pass in, we give it our Boolean series.
EXPENSIVE
line
B
ovals right bracket.
So we did expensive underscore DF equals DF open square bracket expensive underscore bools, our Boolean series variable, right square bracket. Okay. And you can kind of think of this as a fancy, remember we used slicing syntax on our lists in the first tutorial to pull out specific items from a list. It's very similar to that syntax, but we're actually using our Boolean series to tell pandas which rows to pull out. We'll go over that again, but I'm going to press enter.
In left bracket 17 right bracket.
Remember, we saved a variable, so we didn't get anything out as output. But let's take a look at that variable.
EX.
Let's do length on this variable.
X
LEN
len
EXP ENIVE
expensive line
DF.
DF.
So I'm putting expensive
Right
underscore DF inside len open paren, expensive underscore DF close paren.
Out left bracket 17 right bracket colon 239.
239 items. So we have a new data frame that has 239 items. Okay. And you could look at it manually, but now what we have in here is all the items are expensive. Okay. Every item in this new data set is had a room that was over $1,000. Okay. So we can do things like, well, what would be the mean of the prices of these rooms? It would probably be more, right? But let's just try it out. So we could do
EXP
Ensive line
F
I did two lines.
D
line
D.
So I did expensive underscore DF
space
dot price dot mean.
dot
PRICE
price
MEAN
mean right paren.
So it's expensive underscore DF dot price dot mean open parenthesis close parenthesis.
Out left bracket 18 right bracket colon 2,481.
So if you only take the items that are over $1,000, then the mean is really large. It's actually it's like $2,500. Okay, which doesn't tell us that much. But you could do other things like maybe maybe I want to know what neighborhoods are the most expensive. So we could do DF, or no, not expensive underscore DF dot neighborhood
EXP
Ensive line
D.
So I did expensive underscore DF. I filled it in. Dot neighborhood
NEIG
neighborhood
See, I'm using
neighborhood.
the tab to fill things in.
dot
So it's expensive
Dot.
underscore DF dot
Colon.
neighborhood. And then now let's do value counts just to count them up because we don't want to go through all that data. We just want it to count it up for us.
dot
VALUE
value line
COUNTN
counts left paren right paren
So it's expensive underscore DF dot dot neighborhood. That tells us which neighborhood that each item is in. Dot value underscore counts. Open parenthesis, close parenthesis. So what essentially this is telling us is it's going to tell us which neighborhoods have Airbnbs that are listings that are over $1,000. Okay.
File quote less
There's
Python
something wrong. Expensive
F
df dot
DF
neighborhood
N 8 bit
hourhood dot
dot price dot value counts.
right parent Riverdale 1 East Flatbush 1 Sheep's Head Bay 1 Flushing 1
This is kind of boring.
Fort Greene
So
1
we actually want to sort this.
Cypress Hills 1
Oh,
Princess
you know what it's doing? It's printing. It's because it I'm so zoomed in that it prints out stuff later. So we actually want to use head as well. So I'm going to press up
colon
and
value
do dot
line
head. So actually we're chaining together a lot of things, and we'll go over it one more time.
dot
HEAD
But let's hear the output, and I'll go over it one more time.
head right paren
So this prints the first 5 items. We were hearing items from the middle, which is not that good.
colon value line counts left paren right paren dot head left paren right paren out left bracket 21 right bracket colon upper west side 23
Upper West Side 23. So there are 23 items, or there are 23 listings that are more expensive than $1,000 in the Upper West Side. That's seems like a pretty pricey neighborhood.
Midtown 19
Midtown 19.
West Village 14
West Village 14. Okay. Okay, so those are very expensive neighborhoods. Any other ones?
Upper East Side 13 Chelsea 13
Those are all sound like very expensive neighborhoods in New York. Okay. So what we did there was we have our new data frame that we created that has rooms that are only over the $1,000 price point. But it has all the other data in it, right? So it's like a new data frame, but the only rows in it are items that are over, the price is over a certain amount. But it still has all the other data in it. So we can pull out the names, we can pull out other items, we can pull out the neighborhood, we can pull out the neighborhood group from this new data frame. So we just then do what we did before, which is pull out some categorical data. So we pull out the neighborhood, then we count it, value counts, and then I did head because we had, it was printing out too many things. Okay, so we just pulled out the first 5 items, and it told us the 5 most expensive neighborhoods. Okay, so that was expensive underscore df dot neighborhood dot value counts, count the data, dot head. Okay, and that tells us the 5 neighborhoods that have the most rooms over $1,000 in the data. You can see this is a very flexible method that you can anything you can think about that you can pose as a question about something greater than, something less than, you can make a new data set out of it. Okay, and then explore only that data set. Okay, so it's a very flexible tool in your toolbox. You make subsets of your data. Okay, I'm going to do a quick little time check because there's something I would like to show you with this, but we may not have time for it. I might just have to gesture to it. Time.
2:22
2:22. We could very quickly go through it. I think we might have time for it. So, I live in New York, as we talked about, maybe briefly before. And I grew up in Queens, here in Queens, and I live here in Queens. Okay. And I say, actually, I didn't get very far in life because I grew up in Queens and I live in Queens. But literally in terms of distance. But I like my neighborhood. It's called Woodside. It's here in Queens. And I want to know some stuff about, let's say I want to know the average price of an Airbnb in Woodside, okay, in my neighborhood. So we'll use something a little bit, we're going to use the exact same technique. We're going to create a Boolean series where if the neighborhood is Woodside, it will be true. That row will be true. And if it's not Woodside, it'll be false. Then we're going to use that Boolean series to create a new data frame. And the data frame will only be items in Woodside. Okay, only be items in the neighborhood Woodside. Okay, so instead of working with numeric data, instead of using numeric data to create a subset, greater than, less than, whatever, like we did with the expensive data frame, we're going to actually use categorical data. So we'll say the data has to be in terms of the neighborhood as a categorical data. And then we'll say, okay, the data has to be in Woodside. Okay, so it has to be in a specific category in the neighborhood column, which is Woodside. Okay, and you can tell I'm in Queens because someone's driving by with a loud. Hopefully you guys don't hear that music. Maybe you do. Let's do Control L to clear our screen.
Email iPod.
Okay, I guess I'll do the mouse to
Nick
focus.
Upper East
Focus is the worst thing in computers.
in left.
Okay. So I'm doing df, or sorry, I'm going to call this Woodside underscore bools. I'm using the same technique. I create a Boolean series. I'm going to call it Woodside bools.
W O O D D E.
I'm going to go a little faster with this because we already did this. I'm just showing you a slightly different technique. Woodside bools equals
space
df.neighborhood
df
dot
N E I G A
bo colon
df.neighborhood
space
equals
equals
is equal to and then I'll use the
space
string quote
W O O D S I D E.
I had to use a capital letter for Woodside because that's how the data is constituted.
Woodside,
I think.
quote
Hopefully. Press enter.
in left bracket 23 right bracket.
Okay, so we have our Boolean series. I'm just going to double check it by doing the mean to make sure there's something in it so that it worked. So I'll go Woodside underscore bools dot mean.
Sideline bools dot right out left bracket 23 right bracket colon 0.00480.
So there is something in it. It wasn't just a 0. So there's it's not a lot of the data. It's a very small percentage of the data, but it's there. And then we'll immediately gonna create a new data frame from our Booleans. So I'll say Woodside underscore df.
W O D F I D E.
Woodside
DF.
Create a new data frame. If you want, you could just sit back and relax during this part. You kind of already did this, but and then equals
space
Woodside df equals and then df
D F
open parenthesis or no open square bracket
df
and we pass in our Woodside
left
bools.
bracket.
This is exactly what we did before. You know, to create the new series, we do df open the square bracket and we pass in our Booleans. Okay. And then it pulls out all the rows for which a value is true. Okay, for which, in this case, for which the neighborhood was equal to Woodside. So Woodside underscore bools.
W D F O L S.
Ols.
So here I have
right bracket
Woodside underscore df equals df square bracket Woodside underscore bools. Okay. And what this does is it creates a new data set. It's a subset of our data where only the neighborhoods that are Woodside, or only the items in the neighborhood column that are equal to Woodside are put into the new data frame. Okay, that's a terrible way of saying it. It's a subset of the data for which the neighborhood is Woodside.
In left bracket 25 right bracket colon.
So now I have a new variable Woodside df. Okay, and let's just quickly, we'll get the mean price. So we'll do Woodside underscore df.
W D D E.
Woodside
D F.
Dot price dot mean. This is just like we did in last workshop.
df dot
P R I C E.
price dot
M E A N.
mean right paren out left bracket 25 right bracket colon 85.09
85. So remember, if you kind of remember from the last time, I think like we could do it again. df price the mean price of the in the full data set was
out left bracket 26 right bracket colon 152.
So in Woodside it's only like $80 or $85, which is pretty cheap. It's relatively cheap. You know, so you know, come to Woodside, I guess. And then one other fun thing is you could pull out the don't follow along with this, but I'm going to show you the flexibility of this approach. When I was working with the data, just preparing this tutorial, I noticed that there's some very funny room names for the cheap rooms in Woodside. So I'm just for a laugh, I'll pull that out. So you don't have to follow along with this if you don't want to. But what I'll do is I'll do Woodside DF.
O W D
Woodside
DF dot price.
DF
Oh, dot. No, in fact, I'm going to sort my new data frame on price. So I'm going to get cheap and expensive. So I'm going to do Woodside DF dot sort values.
O R T S
values right paren.
Okay, and then I'm going to do dot name.
Right paren tick
P
C right
So
paren.
it's Woodside DF or variable dot sort underscore values, and then into that I give price. So I basically say sort the data frame on price from, I think it's from cheapest to most expensive. And then I did another dot, and I'm going to say I want the names. Okay.
NAME.
The name column, and then I'll just get the topmost, the head.
Name. Dot.
HEAD.
Right paren.
Don't worry too much about following along with this. I just doing this to entertain you because they're funny. But that is useful. So basically I take my new data frame, which is only Woodside, my neighborhood. Then I'm going to sort by price. Okay. Sort the whole data frame by price. Then I'm going to pull out the top, the 5 first results, which I believe will be the cheapest rooms.
File quote less Python.
That didn't work.
DF
DF
dot sort values
S
val
price
right paren out left in colon dot
head or dot name
E
dot head.
6,351 room. 15 minutes from Manhattan. 18,501 private room. M in 2BR on Woodside. 37,771 one bedroom 20 mins to ma. Manhattan wow. Cozy. 2.
So that one, so
9.
there's a funny one. It has some emoji which isn't printing out correctly, I guess. I don't hearing it. And it says, wow, exclamation mark, cozy, exclamation mark. So that's one of the rooms. And then another one of the rooms was, it only has the word U in it, like you, like letter U can get to Manhattan. And that's literally the cheapest room in Woodside. It was $28 when I looked at it. And it was you, capital letter, can get to Manhattan in, or you can use a certain number of train lines. I thought that was kind of funny. And then another room says just, wow, cozy. And that costs like $30 or something like that. So the ones that are the cheapest are kind of the most eccentric. And I thought that was kind of a little bit entertaining. Okay. And that kind of also shows the flexibility of combining some of these things. So what we did was we created a data set that was only Woodside. Then we sorted on the price to get the cheapest to most expensive. And then we pulled out the names from the data frame. And then we got the first 5, which is the 5 cheapest rooms. You could also do dot tail and get the last, which would be 5 rooms, which would be the most expensive. Okay. So once you get a little bit used to these methods, you can start mixing and matching, and it becomes a very flexible approach. Okay. So we now have about half an hour, I believe, hopefully.
2:32 p.m.
Exactly. Okay, so what I want to introduce is one more concept, which is correlation. And then I may just kind of gesture toward how you would create line charts as well. But we may not have time to fully engage with that, but there are materials in the written curriculum as well. So we might just have to do that, a little bit of an abbreviated version of creating a line chart. It's a lot to take in anyway, so I think we're kind of covering a lot. But okay, so we've learned indexing. That's creating subsets of the data. I would say if you're going to learn 2 techniques for exploring data, for representing data, then the 2 you want to learn are make a count. That's incredibly useful to just do a count of categorical data. Will tell you a lot. The second thing I'll tell you is learn to do that indexing, learn to use those Boolean series, which will allow you to create subsets of the data. They also allow you to answer specific questions. So you can learn, our question, well, here was, what was the proportion of the rooms that are over $1,000? And the answer was, it's about 0.5%. We got the Boolean series, and then we do .mean, and it tells us, okay, how many of these items is this proposition true? And that's a very flexible. We could also say, well, how many rooms are less than $30? How many rooms are under $100? Or we could say things like, how many rooms have the minimum night greater than that you have to stay greater than a week, greater than 7 days? Anything that's a number, you can use that greater or less than and answer questions about it. Say, what's the proportion of rooms for which, the let me think of other numeric items, that the number of rooms for which the minimum nights you can stay is less than a week, and it will tell you the percentage. That's very useful. And once you create a subset of the data, a new data frame based on that, you can answer other questions. Like you can say, of the rooms where you can only stay for 1 night, what's the mean price? And is it greater than or less than the full data set, or greater and less than rooms where you can stay for more than 1 night? You can answer very specific questions with these 2 tools, only 2 tools, in counting and indexing. These are, I would say, if you're going to learn 2 things, you can get very far with just those 2 tools. Okay, very flexible. And you also see they combine well with sorting, getting the head and the tail. Those are the only, and we're really only using a small number of methods here to do some very flexible stuff. Okay, you learn those 3 or 4 methods: count values, head, tail, sort values, and then to that indexing method that I showed you, where you use greater than, less than, or equal to. And then that's a small number of methods that lets you do a lot. Okay, so let's do something a little more data sciencey. And this is we're kind of coming up on the end. This will probably be the last thing we managed to fully engage with. We'll kind of just put a line charts at the end. And we do have some written curriculum, but we may not be able to get to it. So let's clear our minds, clear our screens. Control L.
In left bracket 30, right bracket colon.
And we're up to 20. We've entered 20 line lines of Python. We're up to line 30 here. And what we're going to talk about now is we're going to try to replace another common visualization type a little bit. But it's going to be a little more challenging. It's not quite as easy to replace, but it is possible to get kind of a certain percentage of the way there. And that is that what we're going to learn to do is we're going to learn to correlate so if we have 2 variables. So if we have 2 columns, each with numeric data, then what we're going to learn to do is find a correlation between those 2 columns. Okay, and what a correlation is, it shows a relationship between the 2 columns, between the 2 variables. Okay, and what do we mean by that? The fancy way to say it is it's a linear relationship. Linear relationship basically means you could draw a line to show the relationship, or you can get a number, which would be the slope of a line. And then that's fancy way to say it. The simple way to say it is, say you have 2 variables. Let's just imagine we have ice cream sales and temperature. Those are our 2 variables. We have the temperature in degrees Fahrenheit, let's say. I mean, I'm in New York. I know Fahrenheit is ridiculous, but let's say we have temperature in degrees Fahrenheit, and we have ice cream sales, okay? Sales of ice cream per day. And then at certain temperatures, how much do the sales, how does that affect sales? So we could use a correlation, and that would suggest what is the relationship between the 2 variables, the linear relationship. So if one goes up, does another one go up, down, or nothing happens? That's basically what we're talking about. If one variable goes up, then what happens to the other one? Does it go up, down, or does nothing happen? That's the direction of the relationship. And then also, how strong is the relationship? So does it go up a lot? Does it go up a little? Does it go down a lot? Does it go down a little? Okay, and that is basically what a correlation is. Okay, and what we're specifically going to talk about is called a Pearson correlation, but it's the most common correlation type, so let's not worry too much about that. And the way we represent this is in a number from -1 to 1. Okay. So if the two numbers are, if one number goes up, the other one goes up, we call that a positive correlation. And that number is, and then the number, that correlation number will be positive. If say one number goes up, the other one goes down, then the number or correlation number will be negative. Okay. And then if there's no relationship, then the number will be pretty close to 0. Okay, the correlation number will be pretty close to 0. Okay, so -1 means you have a negative relationship, that the variables go in different directions. 0 means the variables aren't related really. There's no association or close to 0. And then positive number means that there's some kind of relationship. If one goes up, the other one goes up. And the closer the number is to 1, the stronger the relationship. So if a number goes up by 1, then the other one goes up by a fixed amount. Say if one number goes up by 1, then the other one goes up by 5, then that will be a relationship of 1. Okay, it's perfectly correlated. Okay, and so 1 is perfectly correlated. They're basically the same. And one goes up, the other one goes up straightforwardly, linearly. And then if -1, one goes up, the other one will go down straightforwardly, linearly. Okay, so that's what we're going to calculate. And luckily, Pandas makes this, in terms of programming, this is pretty easy. The hard part is just understanding what you're doing, what the number means. Okay, basically just what I just explained to you. That there's a direction, positive, negative, or no relationship, and that there's a strength, whether it's strongly correlated or weakly correlated. And then that number, one number between -1 and 1 tells you the story of the correlation. Okay, so let's correlate two variables in our data set, or two columns. And two numeric, we only have a few numeric columns. Let's do number of reviews and reviews per month. Those are two columns we have in this data set. So reviews per month is how many reviews come in per month for that listing. And the number of reviews is the total number of reviews. Okay, so let's do df dot number
N-U-M-B-E-R.
and I'm going to let it fill it in. So number
line of line reviews.
So it's df.number _of _reviews. That's our column. Let's do dot corr dot correlation dot
C-O-R-R.
dot correlation. That's short for correlation. Okay. So it's df.number _of _reviews dot corr for correlation. Open parenthesis.
CORR. Left paren.
Dot, and then now we pass in the other column. So it's going to be df dot
D-F.
dot
F. Dot.
and then we're going to do reviews per month.
R-E-V-I-E-W-S.
Review per line month.
Okay, and then close the parenthesis.
Right paren.
So it's df.core, or sorry, df.number _of _reviews dot core, open parenthesis, df dot reviews _ per month, right paren. Okay, and this will correlate the two columns and just give us one number between -1 and 1.
Out left bracket 30 right bracket colon 0.5498675.
0.54. So that basically means, first of all, it's a positive number. That means that when one number goes up, the other one goes up by some amount. Okay, so that means there is a relationship between these two variables, which kind of makes sense. That the number of reviews you have total should in some way correlate with the amount of reviews you get per month. Because it's kind of obvious, if you have a lot of, if a listing has a lot of reviews, they must have some amount, of reviews per month. It's probably going to be high. And in this case, our number, it's positive. So they will have a positive relationship. The one goes up, the other one goes up by some amount. And 0.54, that's a pretty strong relationship. I would call that moderate to strong. If it's somewhere around that middle mark, like 0.4, 0.5, you maybe call that moderately correlated. And then if it's above 0.5, which is a little bit in this case, you could start calling it a strong correlation. These are all kind of subjective, but it's fairly well agreed upon. And then if it was say 0.3, 0.2, 0.1, that would be weakly correlated, not very strongly correlated. Okay, so in this case, it is correlated. You might ask, why aren't these numbers perfectly correlated? If since the number of reviews you have total does depend on the number of reviews they have per month. Why aren't they perfectly correlated? The answer to that is that there's another variable at play here, maybe possibly others, but the one I can think of is how long has the listing been around? Okay, and if the listing's been around a long time versus a short time, then that will affect how much the number of reviews has, how much effect the number of reviews has on the per month has on the total number of reviews. Okay, so it's not the only variable that determines the other. Okay, they're not perfectly correlated. They're only somewhat correlated, which makes a kind of intuitive sense, I think, that these would be correlated in some way. So we could do this, we could try this on one other. I'll just run quickly on one other variable. Let's try to see if the number of reviews and the price are correlated. And, I could see there being, I could make a hypothesis. I could say maybe rooms that are reviewed a lot have higher price, because who knows, maybe they're popular. That's a guess, but let's see if it's true or not. We'll do df dot price dot corr for correlation.
Price.
CORR.
CORR.
So we have df
Left
dot
paren.
df dot price dot corr open parenthesis, and then let's pass the other one in. We'll do df dot number of reviews.
DF.
N U M.
Ver line of line. Colon. Reviews. Right paren.
So we have df dot price dot corr for correlation, left parenthesis, df dot number underscore of underscore reviews, right paren. Okay, let's see if these are correlated. Remember, my hypothesis is maybe they are kind of correlated because, I don't know, maybe that if you have a lot of reviews, you're popular. Maybe you can charge them.
Out left bracket 31 right bracket colon minus 0.047.
Okay, so I would say it's negative 0.047. Okay, so I would say that no, my hypothesis is totally wrong. And in this case, it's, first of all, it's a negative number. So it's, if anything, it's negatively correlated. If one goes up, the other one goes down. But really what this is uncorrelated. It's very close to zero. It's a very small number. And so basically what these are is they're unrelated, that the number of reviews doesn't seem to really affect the price in terms of this data set. Okay, which is also another pretty interesting, factoid or whatever. Okay, so that's correlation. It's a very commonly used statistical method in data science. In general, when people want to show correlations, they'll often use a visualization called a scatter plot. And a scatter plot basically puts dots on a say you have a flat plane. Say you just imagine just the flat table, and then imagine you take a pencil and you just put a whole bunch of dots on the table on that surface. And that's kind of the scatter plot. And what a scatter plot lets you do, if you're sighted or you can otherwise access it, is that it shows you patterns like clusters, and that will usually often also show you whether data is negatively correlated, just exactly what we have here, negatively correlated, uncorrelated, or positively correlated. It may also show you useful things like how many outliers you have, like if there are certain values that are way outside of the norm. That we haven't learned a way to do that with this non-visually. Okay, so that's something a scatter plot can tell you that this won't. But what this will tell you is the relationship in the data, and that's about half of what a scatter plot, or maybe more than half to 70% of what a scatter plot will tell you is that relationship between the two variables. Okay, so we can get that from just making this correlation. What it doesn't tell you is stuff about outliers or certain other kinds of more subtle relationships and clustering. You can get those. It's just quite complicated. It's out of scope in this tutorial. So you would want to look at things like Gaussian functions, which would allow you to, it's a little bit mathematical, but basically you can do, you can look for outliers. You can also just kind of look for really big numbers in the data set through methods that we've learned already. which might tell you a certain amount of that. Okay, but if you want to get fancy and kind of more formally look for outliers, you can use Gaussian functions. Okay, which is I would say harder than what we've been doing here. So, but just know that it exists for our non-visual use. Okay. So I would say, you know, bar and pie charts were a strong win with the non-visual approaches. You can really pretty well replace a bar or pie chart with non-visual methods. Scatterplots definitely more difficult. Unfortunately, scatterplots are also maybe Chancey is here. She does a lot of tactile graphics. Scatterplots are also pretty harder to get through tactician through feel on a tactile graphic. Line charts and stuff definitely work better, I think, and other kinds of visualizations. But you know, scatterplots are a little tricky. You might get some use out of it, but okay. So we only have a few more minutes. I wanted to do time.
2:49 p.m.
We have 10 minutes. I'm just going to quickly gesture toward how you could do time because we have a very limited amount of time, and I want to kind of give you a little bit of the philosophy of all of this interaction at the end. But essentially what you want to do in time is, and I will point you toward the written tutorial, but essentially what you want to do is that there's a special function in pandas that will allow you to take a time column and convert it into a form that you can use. So it looks something like this: pandas
dot
pandas dot to_datetime
datetime,
and then you can pass in a column, and it will make it into a special format that will allow you to do time-based things with it. So it would be df. The only time column in this data set is called last review, when the last review came in.
review.
So here I did
right paren.
I did df or pandas.toDatetime, to_datetime, open paren, and then I passed in our df.lastReview column. That is it's time data. I'm going quickly with this, so I just want to give you a general idea of how to do it. I wouldn't follow along now if you're doing this live. And then I'm going to save it to a variable. I'm going to call the variable, I'll just call it dates.
Equals.
Okay.
In left bracket.
So I have now a column that's dates.
48,890 NAT.
Yeah, a lot of them are empty, but some of them are not, hopefully. And then you can then use that. You can do year dates dot dt dot year
dot d out left bracket 34 right bracket colon.
And then we can count that.
In left bracket 30
dot value
right 2018.06.
So now we're hearing the output there. Let's run it again because
in left colon out left bracket 36 right bracket colon 2017.03205 2016.02700 and
essentially this is telling us how many items from each year there are in the data set. Okay, so this is kind of fairly useful time data, and then you could just sort this and then get an idea, okay, over time, how does something change? Okay, this would be more useful if it was when the listing was first posted or something like that. But if you look at this, and I encourage you to take a look at the written curriculum that goes into more detail on how to perform this operation. But basically what we're doing here is we're turning a column into a specific format that allows us to manipulate it in terms of time. Then we're using that to pull out the year. Then we're using our familiar value counts to count how many of each year we have. And then if you sort it, you'll get a sense of how things change over time. And you can actually even add in that percent change function or method that we used at the beginning. And you'll get something very similar to a line chart where you get the idea of the percent went up, the percent went, the percent is going up by a certain amount per year or down a certain amount per year, which is exactly what a line chart tells you. Unfortunately, I don't want to keep you guys longer than you're our 2 hours. So if you're interested in how to replace these line charts, I recommend looking at the written curriculum, and feel free to send me questions and stuff as well. Okay. I will say, yeah, so, and that percent change, it really does actually give you a fairly, this is harder to make, but once you have it, if you get an account of all the different years, then get the percent change, you do get a sense of exactly what you would get with a line chart, which is how steep is the change, how radical is the change between these different time periods, the different years. Okay. Making these kinds of visualizations of time can get pretty tricky non-visually, but once you make them, you can get a pretty strong idea of the change in the data set. Okay. They're not as easy to make as the bar charts in terms of programming, but you do get a very strong sense, just like you would with a line chart, of the change over time. It's maybe not quite as direct or intuitive as what Sarah will show you in the coming 2 weeks with sonifications, where you'll hear the change with the pitch, but it is pretty okay. It's not terrible. It's easier to replace than the scatter plot. Okay, I'm clearing my screen.
In left.
We're pretty much at the end of this workshop. I'll just want to give you a little bit of I want to point out some of the things to keep in mind, and give you kind of the usual pep talk for the non-visual data analysis. First of all, is that what was the basic methodology we have here, which is to create an interactive objects that we can then manipulate. So data frames, series, and then to ask for very specific things from them and to get very specific results back. It really, when you get fairly adept at it, when you get even a little adept at it, or when you get fairly adept at it, it really feels like having a conversation with your data. It really feels like talking to your data. And you can get a very strong idea of the relationships, the content, and so on, of the data set through this method. And I would say possibly even if you get quite good at it, you really, honestly, you won't be missing the visualizations that much. You can really get a very strong sense of the data set through these methods. Now, are there downsides? Obviously, I would say in some cases, the main downsides I would say are, if you're working with sighted colleagues, and you want to share a representation of the data, so I will say sighted people love charts, and they're often persuaded by them and so on. So if you want to work with sighted people, it's helpful to actually make the visualization if you can. It's hard as a blind visual impaired person to make a visualization, but if you're working with sighted people, there's advantages. The other thing, so if you're working with people, that's one important reason that this is not a great approach, specifically. The other one is the other disadvantage is that you do need to kind of know what you're doing. So I'm trying to say this in a more diplomatic way, but I would say often visualizations can be a little bit of a kludge, that people kind of do them out of habit, and then they look at the data and gives them some kind of general idea of relationships and so on. And a good visualization is a good visualization, but often I feel like sometimes visualizations are a slight crutch for data scientists. And unfortunately, if you want to do things this way, this non-visual way, you will kind of maybe need to know what you're doing in terms of the types of data you're working with, how you're transforming them, and how you're representing them in a more specific way. Doing things like the way we divided the data to get the proportions or to get the percent change. They do kind of, or to get other useful things like the correlation. There's things we didn't even get into, but there's things like variance, standard deviation, and so on. You really do need to know what those mean in order to make them useful to you. So you may need to think about the math a little bit more, or to think about the types of data that you have a little bit more. So unfortunately, there's no real shortcuts for the non-visual stuff, but when you get there, it's a very powerful way to interact with the data. And then I guess I'll leave you on, let me just, I wanted to say one more little
Emacs
thing.
and
I'm looking at my notes.
you might need to actually know what you're doing.
You might
But
need
that's
to
mostly
actually know
good.
what
You might
you're
need to actually know what you're doing. You might need to disadvantage, not as immediate. Not as
Yeah.
good for collaboration with cited or disadvantage, not as immediate.
So I
Not
would
as good for
say,
collaboration with cited or
and the
persuasion.
other thing is,
Some types of insights are harder to access or take longer.
we're going to make identifications in the next 2 workshops, and those are much more direct ways to experience the data. Okay. And they're much more shareable in a lot of ways. Okay. And I do think sonifications are going to be, Sarah will talk more about them, but they're going to be much bigger than they are in the coming years. And I do feel like they will help us out in these areas for when we're trying to create stuff to share with sighted colleagues. Because what I've found is that while sighted colleagues, they maybe won't want to look at these kind of like, non-visual representations we have quite as much. They really do often do like a sonification. So I have high hopes for sonifications in the coming years. I think they're going to be bigger. We're going to do more of them in the next 2 workshops as Sarah takes over. And I'll just say, I've been really enjoyed teaching these 3 workshops. It's kind of a privilege to teach workshops specifically for my fellow blind VI people. I don't get that opportunity that often. Usually I teach sighted people. And it's quite nice to teach you all how I actually do data science, which is in this non-visual mode. So I we'll end there, except for question and answers. So thank you all. Okay, I will leave the recording on for questions and answers. And then we will also then turn off the recording if people want to ask off mic. Okay, so we'll leave the recording on for now. And if anyone wants to get on the mic and ask a question, this is the time. Or if the helpers have questions from the chat.
The only thing we've seen recurrent in the chat is a couple of people having trouble loading the data frame from the URL. Yeah, and we think upon some examination, we believe that for these people, it's probably either a problem with their network, so it took too long to load because their internet's too slow and IPython timed out,
Yeah.
or maybe they have some sort of like proxy enabled, so we encouraged people to go look in their network settings and make sure you don't have some like barrier, like firewall, I suppose, between you and whatever you're downloading. So, but if you're still having that issue, we do encourage you to maybe come to office hours, because this is not exactly an issue with the code so much as something funky going on with your computer.
And one other additional thing so in the tutorial, when I update the tutorial, I will add a link to download the CSV, and then you can try to place the CSV in your home folder and import it that way. The URL is definitely a lot easier if you can access it. Okay. I would say, the most likely, if you're having a problem with the URL, 90% it's a problem with the way you type the link, or in the copying and pasting. I would say that's the most likely reason, or the most common reason and this is also when I do it with the cited workshop participants, that's almost always the reason. And then the next reason is, like Sarah said, network issues. Now, if you're on the Zoom meeting, chances are, you're on the internet. So hopefully, you check that box. I will say that in the last year or so, GitHub is getting more fussy with what IPs they accept requests from, and so on, but they should accept from most. I am often on my, very suspicious VPN server in, whatever it is, Rotterdam or something like that, that a lot of websites don't like and Cloudflare doesn't like, and GitHub still lets me look at these pages and import the data sets and all this kind of stuff. So I would say triple, quadruple, and quintuple check your URL. Remember, it's http:// bit.ly/NYCBNB. And I would also try both HTTP and HTTPS. just try both of those. Okay. I did HTTP because I think it's the most likely to work, but you could also try HTTPS as a possibility. Okay. Those are the things I would try. Okay. I would hope someone ask a question. Just make me feel happy. I love to hear your, I love teaching in person and hearing people's voices and hearing the noise and commotion and everything. And that's you asking questions on the mic is the closest I can get. So.
Hey Patrick, it's Marco.
Hey Marco, how's it going?
Hey, it's going all right. Thanks again for this whole series here. I put this question in the chat, but I just wanted to see if your take on it. So we talked a lot about the data sets that we have and kind of understanding it from a text point of view within the terminal. But I could take this Airbnb data set, grab a subset of something that I want to build as a bar chart or a line chart, and then as long as I gain access to those values within a normal Python data type, like a dictionary, I could then funnel those values into like something that's going to write SVG code for me so I can actually create a tactile graphic out of that. So I was wondering, like an elegant way of taking like a subset, like if we grab price and the name, I guess, of the listing, how to take that and create a dictionary straight from a subset. And I think Helper posted, I guess Pandas has its own to_dict, or there's a method that does that for you, which is pretty awesome. I was just wondering your thoughts on that.
Well, would it help to create an SVG file directly, like an SVG file of what cited people would have? Would that be helpful, or?
I mean, I would be able to do that because that's the whole thing that I've been working on is building SVGs.
So you can do that already, or do you want me to show you how to do that?
No, I know how to do that. I teach people how to do that. But
Yeah,
it's
so
just
what you want is a representation, which would be something like the lengths of the like, can you describe how the dictionary should look? And then I could kind of maybe advise it. Because the only thing is, I've worked with SVGs, but in a very lazy way. So, you know what I mean?
okay.
Yeah.
Yeah, I mean, like let's say to create like a line chart, you would just use the polyline SVG shape, and then the points, you would have to you have to kind of set up the axes of the canvas, take the data that you're getting from the data frame, and you're kind of piping that in, but then you have to massage the data in a certain way to get it to scale properly to fit
I was
across
gonna
the
say you
page.
probably will need to normalize it. I would say basically what you're talking about is something kind of fairly it either has something existing for it, in which case, I'd probably wind up Googling around the same as you. And I encourage you actually to maybe drop me an email, and I'll do a quick Google. Or does someone on the chat on the call know about this? Or?
So GeoPandas does this. GeoPandas has a column for polygons and SVGs. So the geospatial GeoJSON community has already done some of these things. So if you go and check out GeoPandas, you'll get some of this stuff. And alternatively, stick with that. That's probably the cheapest way to get SVG.
Thank you, Tony.
Yeah, I'll stop there.
I just want to say this is the person who just answered there is Tony Fast, who is a contributor to Project Jupiter, and I had the pleasure of working with Tony last year on a project with Space Telescope Science Institute to make their notebook applets more accessible. You can check out that project. It's called Notebooks for All. And I will say Tony is he's been working on creating a version of Jupyter Notebooks that is more readily accessible to us, and outputs things in more useful ways and so on. So if you're interested in that, maybe just send me an email and I'll put you in touch with Tony. I know he's looking for testers, and I heard that Tony might be doing some kind of event coming up related to that as well. So I'll let you guys know by email.
I'm super interested in tactile SVGs, especially on like tablets and phones. So let's get in touch, Marco.
Yeah, definitely. Because I know the one thing is like to get the SVG out, but also make it human readable so we can get through the file and add our own things to it, which is what I've been doing with like my own website.
Yeah,
Sweet.
we can work on that stuff. We just have to do some narcy things with pandas. They're outside of the scope of here.
Yeah,
Yeah,
exactly. I would
totally.
say definitely possible. It's just a matter of how to get from point A to point B in the easiest way, and I'll put you guys in touch.
Sweet.
Does
Thank you.
anyone have? Thanks, Marco. Does anyone else have any questions they'd like to get on the mic and ask? And that was a fairly, advanced question, but you can ask a question about anything. It doesn't have to be. Okay, I live for those awkward pauses, but you have to do them, or otherwise people won't ask. But I think then we'll end the recording, and I'll stay on for a minute or two if anyone has any other questions. And we're looking forward to seeing you for the fourth workshop in the series that Sarah Kane will be leading on just the same time next Tuesday. So thank you all.